Hey everybody. We are now looking at Unit 3.4, I should say Section 3.4. We've been talking about inequalities, learn how to graph them, how to decide if a number is true or works for a given inequality. We also learned how to solve them. Now we're going to talk about multi-step inequalities. So multi-step inequalities are inequalities that have variables on either in multiple places in the inequality. And basically what it means is we have to go through multiple steps to solve the inequality. It's not as simple as just there's one variable on one side and we solve from there. So there are 5 steps that we're going to think about for multi-step inequalities. We're really doing the same thing we've been doing previously. The first step is to use the distributive property if necessary. Okay, if necessary. We don't know for sure if we're going to have to do that. Second is to combine like terms if necessary. The third is to move all variables to one side. We want to get all of our variables on one side and all of the constants to the other. Okay, if there are variables on both sides. Obviously, sometimes you won't. You're going to see that in a second. Fourth is to solve the equations with adding, subtracting, multiplying, and or dividing. And then fifth is to graph the inequality on a number line. Remember, greater than or less than is an open circle. Less than or equal to or greater than or equal to is a closed circle. Okay, we're going to do 2 examples just to see how this works. So first example, we've got 3 times the quantity k minus 5, end of quantity, plus 9k is greater than or equal to 3. I'm going to zoom in just a little bit so you can see a little bit better. Okay. All right, so to solve this, let's do step 1. It says use a distributive property if necessary. Is there a situation here where we could use a distributive property? Yes, right here. I'm going to distribute this 3 to the k. So I've got 3 times k, 3k. Then 3 times negative 5, that's minus 15. So now I've got 3k minus 15 plus 9k greater than or equal to negative 3. That was step 1. Step 2, combine like terms if necessary. On this side of the equation, we have a 3k and a 9k. We can add those together. 3k plus 9k is, I'm actually going to rearrange them so you can see that. 3k plus 9k minus 15 greater than or equal to negative 3, right? So I've just moved this 9k and 3k next to each other. We can combine them now. We've got 12k minus 15 greater than or equal to negative 3. How do we solve? We want to isolate the k, so we're going to add 15 on this side. If we're going to do that over here, guess what? We got to do it over here. We got 12k is greater than or equal to negative 3 plus 15 is 12. Negative 3 plus 15 is 12. Okay? Then we divide by 12 over here, divide by 12 over here. We don't have to do anything in the sign because this is a positive. We get k greater than or equal to 12 divided by 12 is 1. That's our solution. Lastly, we've got to graph it on a number line. We're going to draw our number line. We've got 1 greater than or equal to, so that's going to be not an open dot, but a closed dot, closed circle. And it's a greater than, so that means it's going to the right of our number 1. Okay, pretty straightforward. Let's look at example number 2. Example number 2, if you can see that, I'm going to try to make sure it's in focus. Awesome. So example number 2 says, 5f plus 8 is greater than 2 plus 6f. Okay, I'm going to go through the steps. I'm going to read them. I know you can't see them. Number 1 is use a distributive property if necessary. There's no space to use distributive here. Number 2 is combine like terms if necessary. Well, there's no like terms. I've got 5f and 8, 2 and 6f on either side of the inequality. Step 3, move all variables to one side and all constants to the other. Okay, we want to get all of the f's on one side and 8's on the other. Now when I look at this, I'm going to start with the f's. I've got 5f here and 6f here. Since I've got more f here, I'm actually going to try to get rid of the f on this side. So I'm going to subtract 5f here. If I do that on that side, I have to do it on this side, minus 5f. This becomes 0, so we only have 8 over here. Still greater than, because we haven't done any multiplying dividing by negative. Then I've got 2, and then 6f minus 5f is f. 1f plus f. Okay? Now I got to get all of the constants onto another side. I've got a 2 here. I'm going to subtract 2. If I do that here, I've got to subtract it here. 8 minus 2 is 6, greater than f. Guess what? We're done. It's that simple. 6 greater than f. I draw my number line. I've got a 6. It's a greater than. 6 is greater than f, so f is less than 6. So it's an open circle. F is less than 6, right? F less than 6. That means it goes to the left. So that's all that there is to it. It's really the same steps that we've been using before, but make sure you're using distributive property, combining like terms. and just following through step by step, being methodical with how you solve these.